This is the last question in the set. So it's sine x, sine 2x, sine 3x equals 2 sine x plus or times 2 cosine x plus 1. Okay, so maybe the first thing that I'll do is, well, we can definitely see that there's not the same x's here. There's 1x, 2x, 3x, 2x, 1x. So we need to make them, ideally, we're probably going to make them into single angle identities, but I do see a little bit of a shortcut in that this sine 2x, when I multiply out these brackets, I'm going to generate a plus sine 2x, and those will match, so then that kind of takes care of that, so I don't have to worry about that in my expression. So I'm going to rewrite it like this, sine x plus the 3x I'm going to rewrite as sine 2x plus x, okay, and then plus sine 2x, okay, and this x here, the sine 2x and the sine 2x come from the same place. So then if I multiply out these brackets, I get 2 sine 2x cos x plus sine 2x. Okay, so now I have my sine 2x is matching. All I need to do then is keep that, I'm just going to leave it because those two pieces are already single terms that match on both sides. You know, if this was an equation, I would probably subtract them from both sides, but since it's an identity, I just need to make sure I keep those. And I'm going to convert these into, use the sum angle here and a double angle here, and I'm just going to convert this all to single angle identity. So that's my strategy. So I end up with sine x plus sine 2x cos x plus sine x cos 2x. Okay, so that's going to be, so if you're wondering where that came from, this turned into all that using my sum identity. I'm going to leave the sine 2x as is, plus sine 2x. Okay, and then I'm going to convert this identity here into its double angle form. So it's going to be 2 sine x cos x times cos x, and then plus sine 2x. And again, I'm just going to make sure, this is just more of a formality. I just need to make sure I keep track of that all the way down. Okay, so on the right hand side, I've got to just clean up the right hand side a little bit here. I'm going to end up with 4 sine x cos x squared. Okay, so I'm going to make sure I keep track of that. So I'm just going to keep that to sine 2x. And then I'm going to work on the right hand side here, the left hand side here. And basically, I'm just going to try to generate this expression. And I can see I can generate that expression in here. Okay, so I'm going to end up with sine x plus 2 sine x cos x, and then times the cos x, so there's my cos x squared. So I have my 2 sine x cos x squareds. I just need 2 more of them, and I got to get rid of this sine. So I'm going to convert this cos 2x into an identity. Now I have a choice of 3. The one that will help out the best is going to be the 2 cos squared x minus 1. Because what's going to happen here is the sine x is going to multiply with -1, allows us to cancel out that sine x, and then we can combine the like terms. So here's my plus sine 2x, okay, and that's going to match there. And then I'm just going to expand those brackets and combine like terms. So I get sine x plus 2 sine x cos squared x plus 2 sine x cos squared x minus sine x. Okay, those sine x's cancel out on that side, plus sine 2x equals the right hand side. Okay, so that again matches. When I combine those terms, okay, I end up with 4 sine x cos squared x plus sine 2x, and that's going to equal the right hand side, and that's my identity solved.